All right, just in case you missed these notes in class. So we're going to graph quadratics, but let's first start with just a linear function. So y equals x is a linear function, right? You plug in -2, so I'd say y is equal to, and then we plug -2 in right here. That would tell us that y would be -2 when you plug in -2 for x. You plug in -1 for this x right here, it'd be y is equal to -1. And so on and so forth. You plug 0 in, y would also be 0. You plug 1 in, y would be 1. You plug 2 in, y would be 2. We've graphed the function y equals x. It goes right through the origin, and then it just goes up like this, right? You plot all of those points, and then we just draw a line going through this plane. So this is specifically called a linear function. So a linear function is a polynomial with degree 1. Because technically, right, there's a degree of 1 on this x. So let's take a look at our first quadratic function as a graph. So here it's telling us to plug -2 in for x. We say y is equal to, we plug -2 in for that x. We always put it in parentheses, so -2 parentheses squared. That would tell us that y is equal to 4. So then we just plot that point, -2, +4. Now let's do it with 1. So we say y is equal to -1 squared. Again, always use parentheses. We get y is equal to 1. So you plug in -1, you get 1. Next we plug in 0. So y equals 0 squared. That is just 0. 0 times 0 is 0. And then let's try +1, so y equals +1 squared. That's going to give us y is equal to 1. So 1, 1. And then last but not least, y is equal to 2 squared, which would give us y is equal to 4. So this graph, check it out, kind of doing something like this, where it comes down, goes to the origin, and then bounces back up. Just like that. And that is a graph of a quadratic function. So let's talk about this. A quadratic function is a polynomial with degree 2. See, the degree on this x is a 2. So let's talk about the quadratic equation a little bit. The quadratic equation y equals x squared is called the parent function. We call it the parent function because all other quadratics come from this one equation. What happens is we just add and subtract things, and it just shifts where that parent function is on the graph. So let's take a look at this. Properties of the parent function of a quadratic. It's vertex. The vertex is the point where the quadratic turns. So right here is where it turns, right? It's going from a decreasing to an increasing function, okay? So the vertex is where it turns. This vertex is at 0, 0. The axis of symmetry, actually we'll just label this the vertex right here. The axis of symmetry is this line, let's do a different color, brighter, is this line that runs right down the middle of the quadratic. We call it the axis of symmetry because it's symmetric, right? This side is symmetric to this side from that axis of symmetry. It's a vertical line, so it's an x equals. In this specific example, the parent function x equals 0 is the axis of symmetry. Y-intercept, where we cross the y-axis, which is right here at the origin. So this is also our y-intercept. So we would say the y-intercept is 0, 0. Furthermore, the x-intercept, where we cross the x-axis, is at the same spot. So this is the x-intercept. So again, we get 0, 0. When speaking of domain, we're talking about all of the possible x values that we could plug into this function y equals x squared. There's actually no restriction to what x values you could plug in. You could plug in 1, you could plug in 1.5, you could plug in 0.0001. All of the x values that you could possibly think of are okay to plug into this. You can also see this as this is going up and to the right and up and to the left. So we're actually going to the left forever and the right forever. So if that's true, and we get all of these values included in the middle, then what we can say is all real numbers for the domain. Remember, the symbol for that is kind of like a 2-bar or double-barred R. So that's the all real number symbol, which you could just use this, and that's good. Okay. Speaking of range, range is all the possible y values. So this one's a little bit easier to look at from the graph. So as you can see, the y values, the lowest we can possibly be is 0, right? This point where it bounces, and then it's just going to go up and up forever, right? So we would say y is greater than or equal to 0. And that would be the range of this function. All right? So let's take a look at another one. Y equals negative x squared. So let's just build that table. In the middle here, this bolded one, we're always going to plug 0 in. So let's plug 0 into this equation. We would have y is equal to negative, and then only into the x do we put the parentheses. So the parenthesis is not in front of the negative, it's behind the negative. So we plug in the 0 and we square it. This is going to give us y equals negative 0, which is just 0. So we get 0 when we plug in 0. So then let's plug in 1. Well, we go y is equal to negative, parentheses 1 squared, which that gives us y is equal to negative 1, technically, because 1 squared is just 1. So this is y equals negative 1. Okay, so let's try 2. So y is equal to negative 2 squared. Again, negative's outside the parentheses, so we square the 2. So that gives us y is equal to negative 4. And then there we go, negative 4. All right, let's try negative 1. So y is equal to negative 1 squared, which we square negative 1, that becomes positive 1, so that's negative 1. So we get negative 1. And then y equals negative 2 squared. That's going to become y is equal to negative 4. So then we have this function, 0, 0. We have 1, negative 1. We have negative 1, negative 1. We have negative 2, negative 4. And we have positive 2, negative 4. So if you take a look at this function, it's that same exact function we just drew, but this time it's opening down. Now I'll give you a hint, this negative on the outside is the reason that it's opening down. Okay? So if we're going through here, the vertex, again, is at 0, 0, right at this origin. It's the spot where it changes direction. So here it's going from increasing to decreasing. Axis of symmetry, right down the middle. Right there, gives us x equals 0. Y-intercept, 0, 0 as well. X-intercept, 0, 0. Domain, for all quadratics, is always all real numbers. The range, in this case, as you can see, we stop at a big value. So the biggest value this thing can be is 0. So then the range is y has to be less than or equal to 0, because all of the y's are down here below 0. Alrighty, next example. So negative x squared plus 9. Again, always start with 0, so plug 0 in first. We go y equals negative 0 squared plus 9, so that's y equals 0 plus 9, so that's y equals 9. Okay, let's plug in 1, so y equals 1, oops, not 1. We're plugging in 1, so y equals negative 1 squared plus 9, so that's y equals negative 1 plus 9, which that gives us positive 8. Well, if you plug in negative 1, what do you think you're going to get? Negative 1 squared plus 9. So that's y equals negative 1 plus 9. Hopefully you said positive 8. All right, hopefully you're starting to see a pattern here. Let's plug in 2. So y is equal to negative 2 squared plus 9. So that's y is equal to negative 4 plus 9. So that gives us 5. So then I'll just tell you, negative 2, you plug that in, you're also going to get 5. Okay, so we go negative 2, positive 5 would put us right here. Positive 2 is also positive 5. Negative 1 is positive 8. Positive 1 was also positive 8. And then 0, we got positive 9. So here's our function. Looks just like this. You have to be super careful when graphing. If you graph it really, really carefully, you're going to nail the x-intercepts. If you don't graph it really, really carefully, you're probably going to miss them. So the biggest thing is maybe just go out one more, right? Try to plug in 3. So if we plug in 3, y equals negative 3 squared plus 9. So that's y is equal to negative 9 plus 9, so that's 0. So when you plugged in 3, we got out that 0. So if you plug in negative 3, you're also going to get out that 0. Our vertex in this equation does change a little bit. We're at 0, 9. Axis of symmetry does not, though. We're at x is equal to 0. Our y-intercept, 0, 9, same as that vertex. The x-intercepts this time, there's 2 of them. There's one at negative 3, 0, and then there's one at 3, 0. Domain, always all real numbers, so just always put it. And in this case, were all of these numbers underneath positive 9, so y is less than or equal to 9. All right, so that is that. I want you guys to try that last example, see if you're starting to understand it. Check your answer with the key on Canvas. All right, have a great day.